Question number 5 here reads, find the zeros of the polynomial x cubed minus 6x squared plus 11x minus 6. X cubed minus 6x squared plus 11x minus 6. When you hear the zeros of a polynomial, it's the same as the roots of that polynomial. In the same way you solve quadratic equation, after factorizing, you now obtain the root of that quadratic. The same thing here, are you following, right? This is a polynomial of degree 3. So you are going to get 3 factors, which is the same as 3 roots. Now, how do we solve this problem? How will we solve it? It might interest you to know that once a polynomial can be factorized completely, you can use the all markers assumed factors method to solve and obtain your answer swiftly. Please, I urge you to visit our playlist on mathematics, alright? And then scroll down towards the end, or you can simply type all markers assumed factors method in our YouTube channel, GMaths41's YouTube channel, and you will see the video explaining this method in full. Alright? So let us see how we solve this problem. We move on first by getting the factors of the constant term. So now this is a polynomial of degree 3 because the highest power of x here is 3. Therefore we would get 3 zeros, 3 roots of the equation. Now those roots of the equation must come from here. They must come from here. There is no other number apart from these ones that can produce the zeros of this polynomial. So we're going to pick 3 numbers here that will be equal to the zeros. And that is why I call it the assumed factors method. So the factors I'm going to pick according to this method will be subjected to the fact that if you multiply those factors, you should get minus 6. And then if you add those factors, you should get minus 6 over 1. Are you following, right? Like I said, for detailed understanding of this method, please kindly visit and type all markers assumed factors method in the GMaths41's YouTube channel. You have a playlist, you will see the video explaining this in details. So the factors, I will do that for us. Watch. If I pick minus 1, minus 2, and minus 3, multiply them, let's see. Minus 1 times minus 2 will give us plus 2. Times minus 3 will give us minus 6. Remember I told you if you multiply the factors, you should get minus 6. Then if you add the factors, you should get minus 6 over 1. And minus 6 over 1 is still the same as minus 6, you know that. So add minus 1, minus 2, and minus 3. It would give us minus 6. And hence, the all markers assumed factors here will be minus 1, minus 2, and minus what? 3. Now we are asked to find the root of this equation, of this polynomial, that is the zeros. Now to get the zeros is simply to change the signs of these assumed factors. Are you following, right? Therefore, x cubed minus 6x squared plus 11x minus 6 has the zeros. Has the zeros 1, 2, 3. And the correct option is option C. Option C is the correct answer. We are moving on next to question number 6. And the question reads, if 2x squared minus x plus 3 all over, open bracket, x plus 1, close the bracket, open another bracket, x squared plus 2, close the bracket, is equivalent to a over x plus 1 plus bx plus c over x squared plus 2. Then a comma b comma c is equal to, we don't know. Now how do we solve this problem to obtain the value of a comma b comma c? It's a simple one. This is the question given to us. This problem is taken from partial fraction. And from what I'm seeing in the denominator, we have 2 different types of denominator. This is called a linear denominator. This is called a non-factorizable quadratic denominator. Now, corresponding to the type of denominator we have, we could use certain method to obtain our result faster. Now, I'd like to say this, remember, solving partial fraction problem, we have a general method of doing that. But then, there are some cases the general method would waste our time, and hence, I'm not going to use that. I shall be using what I call the denominator closing method. Whenever you have a linear denominator, this denominator closing method solves the problem perfectly, which is what we have here. Then secondly, in this case where we have a non-factorizable quadratic denominator, I am going to use what I call the numerator free value method. Whenever you have a non-factorizable quadratic denominator, This numerator free value method solves the problem easily. Now let us do that and see. I will come to this. For this linear denominator, I'll ask myself what value of x would make this denominator to be 0. And noting that, I would say let x be equal to minus 1. If x is equal to minus 1, this denominator eventually becomes 0. Now, what would that help you to do? It's going to help you to get the value of a. The value of a now will be obtained from, you come here, okay? So, a will be equal to 2x squared minus x plus 3 all over. We now have to close the denominator of a here. Remember, the denominator is a linear factor. So, if I close it, what will be left will be x squared plus 2. Now, remember that this value of a is on the condition that x is equal to what? Minus 1. Therefore, a will be equal to, I will fix minus 1 here. 2, open bracket, in place of x, you put minus 1, you square it, then minus, open bracket, in place of this x, you have minus 1, then add your 3, divided by minus 1, you square it, and then add 2. So what will be the value of a here? Let's work it out and see. Minus 1 squared is equal to positive 1. Multiply by 2 will give us 2. This is minus times minus, change it to plus. 2 plus 1 will give us 3. Add it to this 3, you get 6. So this will be 6 over. Come over here, minus 1 squared will still give you plus 1. Add it to this 2, you get 3. So the value of a is equal to what? 2. Now let us proceed. Of course, if you look at the option, it simply tells you that the answer you should be suspecting is between C and D. But we don't know yet because we don't know the value of B and C. Now proceeding for B and C, you notice that B and C, they are part of the numerator of this non-factorizable quadratic denominator. So what do? I am going to select x to be equal to 0 from the numerator, considering this. Once I do that, B will become 0, this will disappear, we'll be left with what? C. And so let me write. Let x be equal to 0. With this, you know that this value of x equal to 0 is selected. It's not from the denominator. It is not from a linear factor. Therefore, you are not closing anything. What do? Go over to this and substitute directly. It implies that I'll come to this and then substitute the value of x I got. If you fix 0 here, you're going to get this will be 0, this will be 0, then 3 will be left. 3 over. Come over here, fix 0 here, this bracket will give you 1. Fix 0 here, this bracket will give you 2. 1 times 2 will give us 2. Equal to, we know the value of a. A is equal to 2. So if I fix 2 here, divide it by, fix 0 here, okay, you have 0 plus 1, which is 1. So 2 divided by 1 will give us 2. Plus, come over here, fix 0. What happens to be? It goes up. You'll be left with plus c. So this is going to be plus c all over. Fix 0 here, add 2 to it, you'll get 2. Now with this, we are going to solve and obtain the value of c. Of course, this is an equation and it has fractions. So we need to clear the fractions by multiplying the numerator using the LCM of the denominator. And what's the LCM here? 2. So it's going to be 2 times 3 over 2 equal to 2 times 2 plus 2 times c over 2. Clearly, this and this we go. We use black marker to, blue marker rather, to strike off that. Then this and this will also go. Now if you look at this, 3 will be left. This is 4 and this is c. This 4 will come over here by collecting like terms. 3 minus 4 will give you what? Minus 1. Therefore, the value of c is equal to minus 1. The value of c is equal to minus 1. Wow, this is very good. Already, this option C will be eliminated. Because A, B, C. C here is minus 5 over 3. C here is minus 1 in option D. And that is what we've gotten here. So likely, I'm suspecting this to be the answer now. I have to check for the value of B. If it's going to give us 0. This is no longer the option to be suspected. Alright, now how do we get our B? According to partial fraction, okay? Now, there are 3 constants unknown that we'll have to find the value A, B, and what? C. These are the 3 unknown, out of which I've gotten 2. Is left with 1. Whenever you're solving partial fraction problem and you've gotten all the constants, all the unknown remaining 1, you can select any value in this word for x. But that value must not include the ones you've used. I've used x equal to minus 1. I've used x equal to 0. So can I use x to be equal to 1 because I've not used that? That would be faster for me in exam rather than using a bigger number. You can try this on your own using any other number, okay? Alright, now it implies that this number I selected it at will, not from any denominator. Therefore, I am not going to close any denominator. I'll simply do the same thing I did to obtain the value of what c. Come over here and substitute. Let's do that. If you come to this and you fix 1, 1 squared is 1 times 2 is 2. If you fix 1 here, 2 minus 1 will give you 1. add it to this 3, and then you get 4 over. Come back again, fix 1 here, you're going to get 2 in this bracket, fix 1 here, you get 3 in this bracket, 2 times 3 will give you 6. And that will be equal to a. The value of a is 2. Now if you fix 2 here, and you know that x is equal to 1, 1 plus 1 will give you 2. 2 divided by 2 will give you 1. So this is 1. And then coming over to this, we don't know the value of b. X is 1. According to what I selected, b times 1 will give me b, and then plus c. The value of c is what? Or the value of c is minus 1. Therefore, this is meant to be minus 1. And then I'll divide it by, fix 1 here, you'll get 3 in the denominator. So this will be 43, okay? And so with this, we are going to solve and see what this will give to us. Once again, let us clear the fraction. And what is the fraction here? Meanwhile, look at this, that this is going to give you 2, this will give you 3. So I've reduced this, 2 over 3. The LCM is 3, so I'm going to use 3 to multiply the numerator, respecting wherever it's going to divide the denominator. Exactly what I did here. Now if you do so here, 2 will be left. So this will be 2 equal to, use the LCM 3 to multiply this, you'll get 3. Plus, if you use the LCM to multiply this numerator, it will cancel this denominator. So this will be b minus 1. Therefore, the value of b will be equal to 3 minus 1, because they are like terms, you get 2. Move it here, 2 minus 2 equal to 0. In conclusion, a, b, c, according to what we are asked to find, is going to be, our a is 2, our b is equal to 0, and c is what? Minus 1. Therefore, the correct option here is option D. Alright, option D is the correct option. I hope you learned something from visiting the GMAT 41's YouTube channel. Please, kindly subscribe to GMAT 41's YouTube channel and give us a like. As much as possible, turn on the notification bell so that once we upload new content, you will receive a personal notification. Remember, you must not like mathematics in order to support us. Please, we need your support. Subscribe, please. Subscribe to the GMAT 41's YouTube channel and share our videos so that all the students can be able to watch them. For the remainder of the solution to this past question 2017, question number 7 to number 30, and for all the years, look below this video, you will see a WhatsApp link. Click on it in order to chat with the GMAT 41's admin. Request for the link to our Telegram channel in order to access question number 7 to 30 solution as well as other years.